Good morning everyone. Today I am going to discuss about the grid computing, grid and cloud computing subject. So coming to the first topic, that is scalable computing over the internet. Scalable computing over the internet. So in this grid computing, now I am going to discuss about the introduction. So I am having the contents, that is evolution of distributed computing and scalable computing over the internet. So these two topics I am going to explain in this presentation. So coming to the first one, evaluation of distributed computing. So what is mean by evaluation of distributed computing? A distributed computing system consists of multiple autonomous computers that communicate through a computer network. So distributed computing system consists of a multiple autonomous computers. So those are communicated through the computer networks. So in this task, the distributed way to achieve the result faster than the computing with a single computer. So what is this evolution of distributed computing? So the evolution of distributed computing is nothing but a distributed computing system which having the multiple autonomous computers, those communicate through a computer network. So whatever the task we are giving, that is distributed in a way to achieve the result in faster than the computing with a single computer. So that is the distributed computing. So this is the diagram of the distributed system. So in the middle of the diagram we are having the cloud, that is the internet. We are having the internet. Surrounding that internet we are having so many resources like distribution, large scale, resource management, subscriptions, cooperations. So these are the different users are trying to gather the information through the internet in a distributed nature. So this is the diagram of the distributed system. So the user will be access the data from the internet and they will give the information to the internet. So they will be store the data in the internet and they will access the data from the internet. So this is in the form of distributed in nature. So we can say it is a example of the distributed system. So next, coming to need for distributed computing. To perform computing intensive task in a shorter time span of as a task could be assume a lot of time on a computing. So in order to perform a task in a short limit of time, we have to complete the task. So this distributed computing will take the complete the task that could consume a lot of time on the computing. So by using the distributed computing, whatever the task we have taken, that the task will be reduced in a shorter period of time. Because it is a distributed in the nature. Okay, so that is why the lot of time on a computing task will be reduces. That is the shorter time span. Okay, so examples are astronomical calculations, large scale molecular simulations, etc. These are the examples of the distributed computing system. In order to perform data intensive task that deals with the large amount or large size of data files. So we have to perform a large task. Sometimes in the data intensive we are going to perform the large tasks. So we have to deal with the large amount and large size of the data files. For example, Facebook data, large hardened calendar data are central. Okay, these are the different types of examples of the data intensive tasks. So what is the need for distributed computing? So in order to reduce the period of time, task period of time, we are using the distributed computing. That will be complete the task very fastly and time span will be reduces. So okay, the examples are what types of tasks we are taking? Astronomical calculations, large scale molecular simulations. These are the examples of the computing intensive tasks. If we talk about the data intensive tasks, so the examples are Facebook data, so and central and data large hadron collider. So these are the examples of the need for distributed computing. So next, coming to properties of the distributed computing. So in these properties we are having different properties of the distributed computing like fault tolerance, resource sharing, load sharing, dispatching several tasks to each nodes, can help share loading to the whole system. So fault tolerance means what ma? So if you have any problem between the communication, so if you get any faults or any problems, errors, that will be have capacity to tolerate that problems. So that is called the fault tolerance. Resource sharing. So what are the resource sharing? So already I told that in the cloud we are having different types of resources like devices, storage, hardware, software, and files, and memory. These are the different resources will be available. So those resources will be shared from the network in a distributed nature. So load sharing and dispatching several tasks to each nodes can help share loading to the whole system. So these are the properties of the distributed system. Next, coming to network based systems. So what is mean by network based systems? The distributed computing needs a networked system. In the distributed computing, that needs the networked system for process the management. So we are having three types of network systems, that is LAN, local area network connection, local servers that connected to the local servers. Second one is a NAS or SAN, network assisted storage or storage area network. So this is the local area network, NAS or SAS. Next one is a VMware, virtual machines. So these are the three types of network systems we are using in the distributed computing. Okay, so in the LAN is nothing but local area network. It is connecting to the local servers. NAS is the NAS and SAS is the network assisted storage and storage area network, and VMware is the virtual machines. So these are the three types of networks we are using in the distributed computing. So the evaluation internet into a low cost network medium. The evaluation internet in a low cost network medium has enabled distribution of the process over remote locations by means of cloud computing. So these are the needs of the distributed network based systems. So these are the network based systems. Depending on the network, we are going to distribute the data from one process to the another processor. Next, coming to scalable computing over the internet. Next one is scalable computing over the internet. So over the past 60 years, computing technology has undergone on the series of platforms. So over the past 60 years, the computing technology has undergone the series of platforms and environmental changes. So in the scalable computing over the internet, it is nothing but it is the performance and levels of the internet. It will be discussed here. The levels of the internet will be discussed in this topic. So over the past 60 years, computing technology has undergone a series of platforms and environmental changes. In this section, we access evolutionary changes in machine architecture, that is operating system. It is a software application can run. OS is why we are using OS? In order to run the software applications platform. So OS platform. In this section, we are estimating and accessing the evolutionary changes in machine architecture, that is operating system, platform, network connectivity, and application workload. So these are the changes will be occurred in this platform. So instead of using a centralized computer to solve a computational problems, we use the parallel and distributed computing system uses multiple computers to solve a large problems over the internet. So what is mean by, in the previous we are using the centralized computer, in the previous we are using the centralized computers to solve the computational problems. So now we are using the parallel and distributed computing systems that uses the multiple computers to solve a large problems over the internet. Parallel and distributed computing systems means the parallel computing system consists of multiple processors that communicate with each other using shared memory. So what is mean by parallel and distributed computing system? So in previous days we are using last olden days we are using the centralized computer to solve the computational problems. So now present we have to complete the large and complex task over the internet. So we are using the parallel and distributed computing. So what is mean by parallel and distributed computing? The parallel computing system consists of multiple processors so that communicate with each other using the shared memory, so whereas what is mean by distributed computing system, it contains the multiple processors that connected by a communication network. So this is the parallel and distributed computing. So in the distributed computing becomes data intensive and network centric. So what is mean by network centric? It manages the series of information. To get the series of information. So that is the network centric. So what is mean by data intensive? It handles the data sets on the scale of multiple terabytes and petabytes. That is called the data intensive. So in this section we identifies the applications of we are going to identify the applications of modern computer systems that practice parallel and distributed computing. So what we are discussing in this topic main is we have to identify the applications of modern computer systems in order to practice the parallel and distributed computing. Okay, in this large scale internet applications have significantly enhanced the quality of life and information service in society today. So what is mean by large scale So large scale internet, so in this parallel and distributed computing, we are using the large scale internet applications have significantly increases and improve the quality of the life and information service in the society. So significantly means it is a more attention. So in order to get a more attention, increasing the quality of life and information service in the society. So this is called the computing over the internet. So now next we are going to discuss about the age of the internet. So age, what is in this scalable computing over the internet, we having three types, that is age of the internet computing, scalable computing, trends and new paradigms, and the internet of things and cyber physical systems. So these are the three types we are going to discuss now. First one is the age of the internet computing. So what is the age of the internet computing? So billions people uses the internet every day. So billions of people using the internet every day. Supercomputer sites and large data centers must be provide high performance computing service to huge number of internet users concurrently. It means, so whatever the supercomputer sites we are using, supercomputer sites is nothing but uses for scientific and engineering applications that handle very large database. So what is mean by supercomputers mainly it uses for the scientific and engineering applications that handle the very large scale database or computational problems. So that is why we are using the supercomputer sites and centers that must provide a high performance computing service to the huge number of internet users concurrently at the same time. So because of this high demand, the link pack benchmark for high performance computing HPC applications no longer optimal for measuring systems performance. So what is mean by so high performance computing means HPC. In the HPC, in the previous we are using the centralized computing. In the HPC we are using the centralized computing. So it is the main use of HPC is nothing but it provides the high performance. Okay, so it provides the high performance. So in the and it also measures the optimal services. It also measures the optimal measuring systems. And we can say it is a system performance. Thus it will also measures the system performance. High HPC means what high performance computing. So it is mainly used for high performance system. So in order to get the high performance system, so that is called the HPC. It emerges the computing clouds, instead demands high throughput computing. So in order to get high instead of using the HPC in the distributed and parallel computing, we are using the high throughput computing. It provides the it uses in the computing clouds. It is uses in the computing clouds. It builds with the parallel and distributing technologies. We have to upgrade the data. We have to upgrade the data centers using fast servers, storage systems and high bandwidth networks. So in order to update the data centers, we have to use the data centers by using the fast servers, storage systems, and high bandwidth networks. So these are we are used in the cloud, that is in parallel and distributed computing technology. When we are use the HTC, it provides the more high performance than the HPC. So HPC is mainly used in the centralized centralized system. Okay, so in the HTC we are in the parallel and distributed computing technology, we are using the HTC. It also provide the more high performance than the HPC. So in order to update the data centers, we are using the fast servers, data storage systems, high bandwidth networks. So this purpose is to advanced network based computing and web service with new technologies. So when we are using the HTC in the distributed and parallel computing technologies, it is used to get the advanced network based computing and web services with the new technologies. So that is the age of the internet computing. Next, coming to the platform evolution. What is mean by platform evolution? So from 1950s. So before going to explain this platform evolution, so it is the computer technology has gone through 5 generations. So the computer technology has gone through 5 generations of development, with each generation lasting from 20 to 20 years. 10 to 20 years. So successive generations are overlapped in about 10 years. So what is the platform evolution? In the platform evolution, we are going to discuss about the how many years the technology is developed. From last how many years the technology is growing. So that evolution is that platform evolution is we are going to discuss here. So computer technology has gone through 5 generations of development, with each generation lasting from 10 to 20 years. So successive generations are overlapped in about 10 years. From 1950 to 1970, a handful mainframe including the IBM 360 and CDC 6400 were built to satisfy the demands of large business and government organizations. So 1950 to 1970, we are having developed the mainframes that it has the IBM 360 and CDC 6400 that is built to satisfy the demands of the large business and government organizations. So IBM 360 is nothing but it is the family of mainframe computer system. It covers the complete range of applications from small to large, both commercial and scientific. So that is called the IBM. IBM full form is International Business Machine. So CDC 6400 is nothing but Control Data Corporation. So this is the one from 1950 to 1970. In order to develop the demands of the large business and government organizations, we are using the IBM 360 and CDC 6400. From 1960 to 1980, lower cost. From 1960 to 1980, lower cost mini computers such as DEC PDP 11 and VAX series become popular among small businesses on college campuses. So DEC PDP is nothing but DEC is Digital Equipment Corporation. PDP 11 is a programmed data processor. It is 16-bit mini computer. In the VAX, we are using the 32-bit. VAX is full form Virtual Address Extension. It is developed by DEC. DEC is Digital Equipment Corporation. So from 1970 to 1980, from 1970 to 1990, we saw widespread uses of personal computers built with VLSI microprocessor. So in the 1970 to 1980, we are using the widespread with the personal computers built with VLSI microprocessor. So what is meant by widespread? It is a distribute over large area or number of people, that is called the widespread. From 1980 to 1990, we are using the massive number of portable computers and pervasive devices appeared in wide and wireless applications. So since 1990, we are using both HTC and HPC systems. They are hidden in the cluster, grid and internet clouds. So whatever the technologies we are using in 1990. Those technologies, both HPC and HTC systems, hidden in the cluster, grid and internet clouds. Okay, so I have in the small figure here image, this is the image. So this is the HPC system and HTC system. So this is the evolution of HPC and HTC systems. Through over the internet we share the web resources. So through over the internet we are sharing the web resources. So and massive amount of data. From this diagram we are seeing the explanation of the HPC and HTC. So in this diagram on HPC side, this is the HTC side and this is the HPC. This is the HTC side and this is the HPC side. So at the right side we are having the HPC system. At the left side we are having the HTC system. Coming to the HPC system. So supercomputers, in this HPC system we are using the supercomputers, that is massively parallel processor, or we can say MPPS in shortcut, massively parallelism, massively parallel processor. In the shortcut we can say MPPS, are gradually replaced by clusters of cooperative computers to share a computing resources. So in the HPC side we are using the supercomputers, that is MPPS, nothing but massively parallel processors, or in that instead of that now we are using the clusters. So cluster is a cooperative computers to share the computing resources. The cluster is a collection of homogeneous compute nodes that are physically connected in close range to one another. So here we discuss about the clusters, MPPS and grid systems. So clusters of cooperative computer is nothing but the computers are interconnected which work cooperatively as a single integrated computing resources. So that is called the clusters of cooperative computers. So next coming to HTC side. On HTC side we are using the P2P network, that is called peer-to-peer networks, are performed for distributed file sharing and content delivery applications. In the P2P system we is built over many client machines. The P2P system is built with many client systems. The P2P is built with many client systems. The P2P peer machines are globally distributed in nature. So whatever the P2P network we are using, that is a distributed in nature. The P2P in this HCC system we are mainly discussed about the P2P network, cloud computing and web services platform are more focused on HTC applications than the HPC applications. So in the clustering and P2P technologies lead to be the development of the computational grids and data grids. So if you see this diagram we can understand. So in this HPC system, we are using the MPPS, instead of that we are using the clusters. So in the HTC system we are using the P2P network. It is a distributed in nature and this is a centralized control, and both of this technology we are going to develop the computational and data grids. So this is the explanation of this diagram. In this diagram we are using the different technologies like service oriented architecture, virtualization, RFID and sensors. So in this we are having web 2.0 services, internet clouds, internet of things. So this is the evolution of HPC and HTC systems. Now we are briefly discussing about the HPC system. So for many years HPC systems given the importance on the speed performance. So from many years we are taking the given the more importance on speed performance. So the speed of the HPC system has increased from G flip-flops in the early 1990s to now P flip-flops in 2010. So in the early years we are using the in the HPC we are using the G flip-flops in the 1990s. Now we are using the P flip-flops in 2010. So what is mean by G flip-flops and P flip-flops? G flip-flops is nothing but it is a unit of measurement used to measure the performance of a computer floating point unit. So on one G flip-flops is called 1 billion flops. 1 billion flops. So next P, what is mean by P flip-flops? In the P flip-flops we are using it is nothing but petaflops, can be Measured as 1000 teraflops, it requires the number of computers working in parallel on same problem. So this is the two things. In the 1990s, we are using the G flip-flops. Now we are using 2010, that is P flip-flops. So this is the improvement was driven mainly by the demands of the scientific and engineering and manufacturing communications. So this is the high performance computing. So in this high performance computing, in the HPC, we have a small example that the top 500 most powerful computer systems in the world are measured by floating point speed. So the number of supercomputer users is limited to less than 10% of all the computer users. So today the majority of computer users are using desktop computers or large servers when they conduct internet searches and market driven computing tasks. So this is called the high performance computing. Next, coming to high throughput computing. High throughput computing. So what is mean by high throughput computing? This model pays more attention on high flux computing. The main application of our high flux computing is internet search and web services. So in the diagram, if you see that, we can understand why we are using the HTC computing. So billions or more users are simultaneously using this high throughput computing. The performance goal shift to measure the high throughput or number of tasks completed per unit of time. So the HTC's technologies not only improve the batch processing speed but also address the acute problems of cost, energy savings, security, reliability at many data and computing centers. So this is called the high throughput computing. Next, coming to we are having the three new computing paradigms. So already we discussed in the diagram, that is RFID, that is full form radio frequency identification. Next one is GPS. So what is mean by GPS? In the GPS is nothing but global positioning system. Next, third one, sensor technologies. These are the three new computing models we are having in the high throughput computing. So with the introduction of this SOA means service oriented architecture, and Web 2.0 service become available. So advance in virtualization make it possible to see the growth of internet clouds as a new computing model. The majority of radio frequency identification, global positioning systems, GPS and sensor technologies has the development of IoTs. The internet was introduced. In 1969, Leonard Clark of UCLC declared the networks are still in infancy, but they grow up and become sophisticated. So in this technology, we probably see the spread of computers utilities, which like present electric and telephone utilities will service individual home and office across countries. So this is the advanced virtualizations we are using in the computing model distinctions. So what is the three new paradigms we are having? RFID means what? Radio frequency identification. GPS means global positioning system. So sensor technologies. So these are has developing of IoTs, Internet of Things. The internet was mainly introduced in 1969. That is Leonard Clark of UCLA declared networks are still in fancy, but they grow up become sophisticated. So we are probably see the spread of computer utilities, which like present electric and telephone utilities will services individual home and office across countries. Many people define the term computer. In 1984, John Gaze of Sun Microsystems created the slogan, the network is the computer. So the network is the computer. In 2008, David Patterson of US Berkeley said the data center is the computer. So recently, Rajkumar Bhuya of Melbourne University simply said the cloud is the computer. In this subject, we cover all the clusters, MPPs, massively parallel processors, peer-to-peer networks, grid clouds, web services, social network and IoTs. These things all we are going to cover in this section. So in fact, the difference among the cluster, grids, P2P systems and clouds blur in the future, and some of the people view cloud grids or cluster with uh, modest changes through virtualization. So these are the three new paradigms models we are using in the HPC and HTC systems. So next, computing model paradigm. The high technology computing has argued for many years for a price definitions of centralized computing, parallel computing, distributed computing and cloud computing. So distributed computing is opposite of centralized computing. So centralized computing is nothing but it centrally control all the services, okay, and nodes. So distributed is nothing but it will be distribute all the data to other users. That is the distributed in nature and centralized. So the distributed computing is opposite of centralized computing. The field of parallel computing overlaps with distributed computing to a great extent, and the cloud computing overlaps with distributed computing, centralized computing and parallel computing. So these are the different things we are going to discuss. So this is the centralized computing. In the centralized computing, what is the use of centralized computing? All the computer resources are centralized in a one physical system. It means all resources, that is processors, memory and storage, are fully shared and tightly coupled within one integrated operating system. Many data centers and supercomputers are centralized systems, but they are used in parallel, distributed and cloud computing applications. This is called the centralized computing. Next, coming to parallel computing. So what is mean by parallel computing? In parallel computing, all processors are either tightly coupled with a centralized shared memory or loosely coupled with distributed memory. A computer system capable of parallel computing is commonly known as parallel processor. So programs running in parallel computers are called parallel programs. So this is called the parallel computing. Next, coming to distributed computing. So in the distributed computing, the field of computer science and engineering that studies about the distributed systems. So in the distributed systems consists of it consists of multiple autonomous computers, each having its own private memory, communicating through a computer network. In this, information exchanges in a distributed system and through message passing. All computer programs run in distributed systems called distributed program. It's called a distributed program. Next, coming to cloud computing. So we are having four types of computing. One is centralized computing, parallel computing, distributed computing, and fourth one is cloud computing. So what is mean by cloud computing? Internet cloud of resources can be either a centralized or distributed computing system. The cloud applies parallel or distributed computing or both. So clouds can be built with physical virtualized resources over large data centers. So this is called the cloud computing. Next, coming to distributed system families. So at mid 1990s, technologies for building P2P networks and networks of clusters is designed to establish wide area computing infrastructures known as computational grids and data grids. So in the future, both HPC and HTC systems will demand multiple core and many core processors that handle large number of computing threads and cores. In the future, HPC and HTC systems must be able to satisfy the huge demand in computing power in terms of throughput, efficiency, scalability, reliability. So what is mean? The system efficiency is decided by speed, programming and energy fields. So this is called the distributed system families. So what is mean by efficiency, throughput, scalability and reliability? So in this, efficiency is nothing but, so it measures the utilization rate of resources, is an execution model by massive parallelism in HPC. So for HTC, efficiency is more closely related to throughput, data access, storage, power efficiency,
Madam,
dependability. So what is mean by dependability? It provides high throughput service with quality of service assurance even under failure conditions. Next, adaptation in programming model. It measures ability to support millions of job requests over massive data sets. Next, that is flexibility in, what is mean by flexibility? Flexibility in application development. It measures the ability of distributed systems to run well in both HPC and HTC applications. So these are the different types of the demands of the distributed system families. Next, coming to system scalable computing trends and new paradigms. So in this we are having one type, that is degrees of parallelism. So 50 years ago hardware was bulky and expensive, but most computers were designed in bit serial fashion. In this scenario, bit level parallelism, that is BLP, converts bit serial processing to word level processing gradually. Okay, so BLP means what ma? Bit level parallelism. It converts the bit series, whatever the information we are taking, that information will be converted in the form of bit serial processing to word level processing gradually. Over the years, user graduated from 4-bit microprocessor to 8-bit, 16-bit, 32-bit and 64-bit CPUs. So the next improvement is called instruction level parallelism, that is ILP, in which processor execution multiple instructions at the same time rather than one instruction at a time, one instructions at a time. So this is called the degrees of parallelism. So at the last 30 years we have practiced instruction level parallelism through pipelining, superscalar computing, very long instruction word architecture and multi-threading. So this is the, in this we are having efficient work efficiently with IPL, that is instruction ILP, instruction level parallelism, that requires branch prediction. So in this we are having dynamic scheduling, speculation and compile support. So data level parallelism DLP was made popular through SIMD, single instruction multiple data, and vector machines using vector or array types of instructions. So these are introduces for multi-core processors and chip processors, CMPS. In fact, BLP, bit level parallelism, ILP, instruction level parallelism, DLP, data level parallelism, are more supported to hardware and compilers. So we move from parallel processing to distributed processing. It increases the computing granularity of job level parallelism, JLP. So these are the degrees of parallelism. Next, coming to Internet of Things and cyber physical systems. IoTs means what? Internet of Things. So in this is, we have two types of internet development trends. One is IoTs, another is physical cyber physical systems. So what is mean by IoTs? Internet connects machines to machines or web pages to web pages. Okay, the concept of this IoTs was introduced in 1999 at MIT. So IoT refers to the network interconnection of everyday objects, tools, devices or computers. So IoT has a wireless network of sensors that interconnect all the things in our daily life. These things can be small or large. They can vary with respect to time and place. So this is called the IoTs. Next, cyber physical systems. So CPU is the interaction between computational processors and physical world. A CPU integrates cyber heterogeneous asynchronous with physical concurrent and information objects. So CPU measures the 3C technology of computation, communication and control in to an intelligent feedback system between physical world and information world. So these are called the cyber physical systems. So up to here we have discussed about the first topic in the grid and cloud computing, that is evolution of grid and cloud computing and scalable computing over the internet. So these are the important topic. Thank you, ma.